Hey guys, Mr. Cannon here. So I'm going to go through a kind of brief intro to our next unit, which is our first full HL unit, Theory of the Firm. You need to make sure, you need to make sure that you take notes on this whole section, especially uh, making sure that you're comfortable with all of the material because this is our first brand new HL unit. The graphs are new, the math is new, everything's new, so there's not a lot of review to fall back on. Due dates below, that is on the hub. So the general overview of the next unit is it's called Theory of the Firm. The idea is that we are looking to take the actions of firms or companies and kind of explain why they do what they do, why they exist at all, and then how they make decisions. So it's not, some people sitting in a back room trying to guess on why they set their prices here, why they hire more or fewer employees, but what they use in their decision-making process. The general idea is that the goal of firms is to maximize profit. So basically, they are trying to reduce costs as much as possible, while at the same time increase revenue as much as possible. Now, some firms might have really, really, really low costs and then low revenue, but their profit is still high. So you could have so you could look at something like McDonald's, where they are reducing costs at every single opportunity to pay as little as possible for their goods, and then they could still make profit by selling, a $1 burger if their costs are low enough. Whereas you might look at something like an oil company where it costs a lot of money to run an oil company, so the costs are high, but because the revenue is so high, their profit is still significant, and they're still comfortable running that business. A couple issues below. One of the issues is that there are debates of whether this is the case because some firms, if you only make decisions based on that idea of maximizing profit, you can run into things where public opinion would push back and not what would be the word, not buy from your firm based on things like using dangerous labor practices, moving against certain social norms and things like that. But for the most part, those are our goals, okay? Reducing costs, increasing revenue. Now, a couple of terminologies here. So you're gonna need to make sure you get all these. We are making the distinction now between types of resources. So we have our 4 factors of production: land, labor, capital, and entrepreneurship. We are now making a distinction between fixed and variable resources. So a fixed resource is something that cannot easily be adjusted in the short run. So in the short term, and there are no time limits for the long and short run. It's mostly based on like per industry. So you might say, I have a restaurant. So we're going to use a restaurant example here today. If I have a restaurant, my fixed resource might be I only have 4 ovens. Now, can I get more ovens and install them? Yes. Can I get it done tomorrow? No. My fixed resource might be my actual building, right? Can I open up a new building to increase production? Yes. Can I get it done tomorrow? No, right? So that would be my fixed resource, something that cannot easily be changed day to day, or in the short run, rather. A variable resource is typically going to be labor or entrepreneurship. So it's something that you can adjust pretty quickly. So if I see that if I'm running a pizza restaurant and I am, 2 servers down and there's constantly people waiting for their food, I can hire a waiter pretty quickly, put a sign out front. I get applications the next day. I could hire by the 3rd day, right? So I can adjust that resource pretty quickly. So labor is a big variable resource. The other one would be entrepreneurship. Basically, how much risk am I willing to take? So in business, you might say, like, we're going to stick with things that we know will work and reduce our risk. We might increase our risk by making certain decisions, and I can change that day to day, right? But the big one that we'll talk about is labor. Labor is really easily adjustable and variable. Now, to start off, we're looking at production today. So we are making the distinction between the long run and the short run. Like I said, there is no specific amount of time that says like the long run is after 90 days or anything like that. It varies business to business. Basically, how we're going to define it is the short run. So in the short term is any time period in which at least one resource is fixed. Because over time, all resources become variable, right? You might say, if we're running a pizza restaurant, my labor is variable, my risk is variable, but the amount of ovens and locations is fixed because I can't just change that overnight. But if I look back at like a 10-year period, can I open up a new location and buy more ovens and get them installed? In 10 years, of course I can, right? So resources become variable over time, but the short run is any time in which at least one variable is fixed. So for the example today, I'm going to be looking at, like I said, a pizza joint, and our variable resource would be labor, and our fixed resource would be space, like the actual location. And then in the long run, everything becomes variable. So once, and we'll talk about that later, but the short run is at least one variable has to be fixed. So in our example here, the short run, we can easily hire staff, but we can't expand to a new location. So let's imagine we are talking about a pizza joint. So we're starting in scenario 1 here. And in that scenario, okay, so in that scenario, this is you up here, okay? That is you. So you run a pizza shop yourself. You are taking orders, you are making pies, you are putting them in the oven, you're taking them out, you're slicing them, and you're boxing them, and you're selling them at the register, okay? That is what you're doing. The amount that you're able to produce is considered our total product. So let's say, random number, you're making 5 pies an hour, okay? Now, your obvious total product is limited by the amount that you can do, right? So you're trying to do all of this at once, and obviously your production is going to be limited. So you sit down and you say, what if we hired another cook, okay? Now, as we add labor, I can do that pretty quickly. So labor is our variable resource, and ovens and location would be our fixed resource. So I say, what if I added another cook? Well, what would happen to my total product? My total product is the total output of pies that I can make, or whatever I'm making. So if one person could make 5 pies, maybe you sit down and you go, what if you made all of them? And then the second person was cooking and taking orders, like actually taking it out, taking orders. So you start dividing up your labor and you go, you do this, I'll do this, and you start specializing. As you add a second person, it doesn't necessarily mean that if you make 5 yourself, you'll make 10 total. Maybe the specialization allows you to make more than 5. So let's say you make 5 yourself, and then you hire another person, okay? By hiring another person, maybe after they're hired, you start making 12 an hour, because the amount of specialization each person provides means you can be more efficient, okay? It's not the same person taking your order and then going back and making food and then bringing it back to you, right? So you actually might produce more per person. Now, your total product would be 12 in this case, but really it would just be the amount of pies you make in an hour. What this person adds to the equation would be considered the marginal product. So if you made 5 by yourself and then 12 with 2 people, this one employee would have added 7 pies to your total product. So the marginal product is the additional output that results from adding one more variable resource, in this case, labor. So if I have 5 by myself and I add 1 employee, I take the difference between, well, I added, down here you can see the equation, I added 1 unit of labor and I had a change of 7. So the marginal product for this would be 7, because this 1 employee has added 7 in total product. Now the average product is the average production divided by the number of employees you have. So if in this example, I make 5 by myself, my marginal product is 5, because this one person has gone from 0 to 5. And my total product would be 5, and my average product would be 5. By adding 1 employee, I'm now making 12. So that means my marginal product, this 1 employee, has added 7 pies to my production, my total product. So my marginal product for this employee would be 7. Once I have 2 employees, my average product, it's 12 divided by 2, my average product per employee would be 6, because 12 pies, 2 employees, average is 6. Now, you could continue that, and you can continue doing that math, and I'll show you how in a second. We can say, maybe let's add a third person. We add a third person, and then maybe it goes to 20. So that third person, their marginal product would be 8, because we've gone from 12 with 2 people to 20 for 3 people. And then the average product would be 20 divided by 3, whatever that is, okay? 6 plus whatever, okay. So as I've said, the math is pretty simple here. Let's find a place for my head. So we're trying to find marginal product and average product. Again, marginal product is just the amount added by adding 1 more unit of variable resource, in this case, 1 more employee. So looks pretty crazy, but it's really, really, really simple. So marginal product, we're just trying to figure out how much does 1 more employee add. So we're trying to find the marginal product of our 3rd employee and adding our 6th employee. So here's my unit of variable labor, variable input, which is labor. So I'm trying to figure out how much value is this 3rd employee giving me. Well, when I had 2 employees, I made 5 pies. When I had 3 employees, I made 9 pies. So all I need to do is take the change in total product, which would be 9 minus 5. So the change up here would be 4. So there's a change of 4. How many units of labor is changing? Well, 2 to 1. So I'm looking at, when I add down here 1 employee, I got 4 more pies. So that 1 employee has a marginal product of 4. Now, if I want to see how much value is my 6th employee giving me, so I go from 5 to 6. Well, my production went from 18 to 21. So my change in total product is 3. My change in units of labor from 5 to 6 was 1. And so that means by adding my 6th employee, I'm getting 3 for my marginal product. Now you'll notice these are not identical, because when you have a fixed resource, we'll talk about this in a second, but when you have a fixed resource, there hits a point where adding 1 more person doesn't necessarily give you the same value as it did earlier. Okay? Average product is the same thing. We're just looking at the total product divided by units of labor. So instead of change, we're more considering how much is each worker giving us on average. So if I wanted to find the total product for my 3rd employee hired, I would say we have 3 employees. We are making 9 pies. On average, each employee is giving me 3. Whereas for 6, I have 6 employees. We have 21 pies. Each worker is giving us an average product of 3.5, which again, you'll notice is different than the marginal product. Now we can graph these with units of output, which in this case would be total product, right? Like our actual production or pies here, and then units of variable input, which would be my labor, right? So I can graph all 3 of these. So if I wanted to graph total input or total product, excuse me, I would say, okay, here's my variable labor, my variable input, which would be labor, and my total product, and I can graph this out. So like I would say, okay, for 1 unit of labor, I'm getting 2 output. Okay, so 1 labor, 2 output. For 11 labor, 21 output. 11 labor, 21 output. 9 labor, 24 output. 9 labor, 24 output. And that graphs us this kind of curve here, where we see as we add people to our firm, we make more and more and more. And then eventually we hit a point where adding more people makes us less productive, which we'll talk about in a second. We can also graph out our marginal product and our average product. So average product increases pretty generally. So as we add more employees, on average, each employee makes a little more. And then again, we hit a point where we are less productive, because adding more people to a fixed resource like a single location restaurant makes us less efficient because of something in a second. Marginal product, you'll see, actually goes negative at a certain point. So so this is, again, how much we gain by adding 1 employee. So every employee gained early on adds a ton. And then we hit a point where every employee we add starts to give us less and less benefit, to the point where if we were to add more employees, we are actually going to become less productive, because people are people. But you can graph these out. Keep that in mind. Now, this is the last bit here, the second last bit, is the law of diminishing returns. This is the way that we explain why is it that in the short run, when we add more variable resources, we hit a point where they become less helpful. And I would encourage you to imagine you being in your own kitchen, okay? So let's say you're in a kitchen and you are making dinner for everyone in your family or whatever. So you're sitting there, you're chopping vegetables, you're preparing the meat, you're getting the plates out, you're doing all of this, right? So you can only make dinner at a certain pace, okay? So this is you by yourself. Somebody comes up and says, hey, would you like some help? And you're like, yeah, okay, you take care of vegetables, I'll do meat. Okay, great. So your production goes up because you'll be able to make more just with this one person. So this one person has added a ton of value to you, right? So at this point, the people in the kitchen, the labor, that's your variable resource. The kitchen size itself is your fixed resource, okay? So you're seeing increased returns or increased value in production by adding 1 more person. Another person comes up. How would you like me to set the table for you? You say, great. So that 3rd person comes in, you get them to set the table. This person's doing vegetables, you're doing meat. Your marginal product of that 1 person is high because that 1 person is allowing you to produce significantly more. Now, imagine your 20th person comes in the kitchen. You are in a normal sized kitchen that doesn't fit 20 people. At a certain point, if your fixed resource does not change, adding more people to the kitchen will make it harder to cook, right? Imagine you're just crammed in there and you go, you have 4 people chopping the same piece of meat, 10 people chopping the same vegetables, 12 people trying to set the table. At a certain point, when you add one more person, they will be hurting, right? Another example, and so this is here, if you start adding your 10th person to the kitchen, they are now going to make you less productive and food will take longer to get out. Another great example, I think, would be like decision making. If you're sitting there trying to solve a problem yourself and you're like, okay, I need to decide let's say you're on a team and you need to decide a team name. And you're like, I'm only so creative. I have a couple names, but I think it would be helpful if I had friends to help me with that. So you add one person. Now you have 2 people making a decision. You can bounce ideas off each other and you're like, yeah, this is going better. You add a 3rd person. That's great. As I'm sure most of you know, if you were to get a group of like 20 together, it's going to be harder to make any sort of decision because a larger group means you have to listen to more people and it might take you longer. Final thing I would say would be like schoolwork. If you're doing schoolwork on your own, imagine how productive you are. And then you get a friend to help you. Okay, now you can both do the work together. So you divide parts of your project. So you do this part of the project, I'll do this part of the project. And then that's helpful, right? Your marginal product goes up because that person becomes really helpful for you. Your total product goes up because 2 people can make more than 1. And your average product goes up because you take your new product divided by 2. Once you add 3, 4, 5, 6, once you get a group big enough, and I'm sure you've all experienced this, there is a point where by adding one more person to the group, some people in the group just don't do anything, right? So you add one more person and they go, cool, they'll take care of that part. I don't need to do that. And there becomes a point where the group becomes less productive because it is too big to manage and if the fixed resource hasn't changed, the variable resource just becomes less productive, right? Too many cooks in the kitchen, all that kind of stuff, okay? So this is the law of diminishing returns. And we can see down here already, the graphs are divided into 3, the point where we have increasing returns, decreasing returns, and then we start seeing negative returns toward the end. So these would be our divisions here. So we have this divided into 3, and this last thing, we have our increasing marginal returns. So in the beginning, when you add one more employee, and I'll use the pizza restaurant example, by adding a 2nd, 3rd, 4th, 5th employee, you see huge gains because you can divide up labor. You hit the cash register. You take care of drinks. You make the pies. You take care of the oven, right? So we see big gains for the early employees. At a certain point, you start seeing a decreasing marginal product where every single person added will still give you increased products. So like you can see by adding a 7th employee, I'm still gaining almost 2 units of output per employee, but I used to gain 4.5 per employee, and now I'm gaining 2. So that has changed. And then in the end, we have this area of negative marginal product. That's the point where the kitchen is so full and the restaurant is so packed with employees that adding one more person will actually make you less productive. Now, this is partially because the resource hasn't adjusted, but so you might have just physically too many people in a space, but it's also because people kind of distract each other, and you might have so many people in a restaurant that the employees just don't really do their job. I'm sure you've seen this next time you go to a restaurant, if you see a lot of empty tables, I'm sure you've been like, you're sitting at your table and you're going, I need a refill on my drink. And you look over and there's 5 waiters or waitresses talking to each other. And you're kind of looking at them going, I clearly need something. I'm making eye contact with you. And they're just finishing their conversation. So there are too many employees in a space for them to continue to be productive. And if those like waiters or waitresses in that restaurant, and I've done that before, so I'm not judging, I've definitely been that waiter rather. But if you're sitting here and there's 2 employees and then you add a 3rd one without increasing the fixed resource, they might just be distracting each other and be less productive, which is totally possible. Okay, so we have this graphs divided into thirds, and you can see that on all of these: increasing, decreasing, negative, increasing, decreasing, negative. Okay. Now, what I want you guys to do is I want you to go ahead and complete these example problems. You're going to fill out this table in your notes. I will be checking this in your notes. This will be half of your note grades, and then you are going to plot those out. So you'll want to make sure that you have your y-axis, your y-axis of total product, and your x-axis of units of variable input, which will be your labor. And I want you to graph out your total product, your marginal product, and your average product, keeping in mind that each axis just needs to be consistent with itself. So this one I would do 0 through 60 in tens. This one I would do 0 through 8 in ones. and then graphing that out using the formulas above. Okay. Make sure you have these and the rest of the notes by the day it is due. Thanks, y'all.